Hello everyone, and welcome. I'm excited to kick off today's presentation on geography. On this first slide, you'll see the title Geography, which is our main focus. We'll be exploring how geography shapes our world, from physical landscapes to cultural regions. Over the course of this presentation, we'll cover key concepts, interesting facts, and the significance of geography in our daily lives. So let's get started and dive into the fascinating world of geography. Today, we're going to take a closer look inside our Earth. When we talk about inside our Earth, we're exploring what makes up the planet beneath our feet. It's fascinating to think that Earth isn't just a solid ball. It has different layers, each with unique characteristics. Understanding these layers helps us learn about how our planet functions, from volcanic eruptions to the formation of mountains. This knowledge is also essential for understanding natural phenomena and how they affect our environment. So, as we go through this slide, keep in mind that everything happening on the surface is connected to what's happening deep inside. This is the foundation of our whole discussion about Earth's structure and processes. The inside of our Earth is truly fascinating because it's a dynamic and ever-changing environment. It's not a static place. Instead, it's constantly undergoing processes both beneath the surface and on the exterior. When we say the Earth is dynamic, we mean that it's always moving, shifting, and evolving over time. These changes happen deep inside, like through the movement of the Earth's crust and mantle, which drive phenomena such as earthquakes and volcanic eruptions. But they also occur on the surface, shaping the landscapes we see every day. Understanding these internal and external changes helps us appreciate the complexity and power of our planet, and it's a key part of grasping how Earth functions as a whole. This idea of constant change ties into our overall theme of exploring the Earth's processes and their impact on our environment. Let's take a closer look at the interior of the Earth by exploring its main layers. First, we have the crust, which is the outermost layer. It's relatively thin compared to the other layers, about 35 kilometers thick, and it's where we find the land we walk on and the ocean floors. Beneath the crust lies the mantle, which is much thicker, about 2,900 kilometers deep. This middle layer is made up of semi-solid rock that actually flows very slowly over time, driving the movement of tectonic plates. At the very center is the core, the innermost layer, with a radius of about 3,500 kilometers. The core is incredibly hot and is made mostly of iron and nickel. It plays a crucial role in generating Earth's magnetic field. Understanding these layers helps us grasp how Earth's interior influences everything from volcanic activity to the magnetic forces that protect our planet. This layered structure is fundamental to the Earth's dynamic nature and ongoing geological processes. Now let's explore the layers of the Earth, starting with the crust, which is the outermost layer that we see and live on. It's actually the thinnest of all the layers, ranging from about 35 kilometers thick on the continents to just 5 kilometers on the ocean floors. The main minerals here are silica and alumina, so we call this part Sial. Over the ocean floor, it's mainly silica and magnesium, so that's called Sima. Beneath the crust lies the mantle, which extends much deeper, up to about 2,900 kilometers below the surface. The mantle is mostly made up of silicates and magnesium oxide, and interestingly, it's in a molten or semi-liquid state. This molten nature allows movements that drive plate tectonics. Moving inward, we reach the core. This is the innermost layer and has a radius of roughly 3,500 kilometers. The core is mainly composed of nickel and iron, so it's often called knife, combining nickel and ferrous iron. The core experiences extremely high temperatures and pressure. It's divided into two parts, the outer core, which is liquid, and the inner core, which is solid. These layers are fundamental to understanding Earth's geology and magnetic field, connecting directly to the larger theme of Earth's dynamic interior. Today, we're going to talk about rocks and minerals. The Earth's crust, which is the outermost layer, is actually made up of many different types of rocks. These rocks are the building blocks of our planet's surface. Understanding the variety of rocks helps us see how the Earth's surface is constantly changing and evolving. As we explore further, you'll see how these rocks and minerals are not only important for the Earth's structure, but also for the resources we rely on every day. So, keep in mind that the diversity of rocks is a key piece of the bigger picture of Earth's geology. Let's talk about rocks and minerals. Minerals are solid substances that we find in nature. They can be made up of just one element, like gold or silver, or a combination of elements, such as carbon, sodium, or even natural gases like coal and petroleum. These minerals are the building blocks of many materials we use every day. Now, moving on to rocks. A rock is essentially any natural mass of mineral matter that makes up the Earth's crust. Think of it as a collection of minerals packed together in a solid form. Rocks are naturally formed and are non-living materials, which means they are alive, but they're incredibly important because they form the foundation of our planet's surface. Understanding the difference between minerals and rocks helps us appreciate the Earth's composition and how these natural resources are part of the bigger picture we're exploring today. When molten magma cools down, it transitions from a liquid to a solid state. This process results in the formation of rocks known as igneous rocks. These are also called primary rocks because they are the original rocks formed from the cooling of magma. Now, there are two main types of igneous rocks that we should be aware of: intrusive rocks and extrusive rocks. Intrusive rocks form when magma cools slowly beneath the Earth's surface, leading to larger mineral crystals. In contrast, extrusive rocks develop when magma erupts and cools quickly on the surface, resulting in finer-grained textures. Understanding these types helps us see how different rocks are formed through volcanic activity and geological processes. This concept ties into the overall theme of how Earth's materials originate and change over time. Now let's take a closer look at the different types of rocks. First up, we have igneous rocks. These are the primary rocks that form from cooled magma. Essentially, when magma rises to the surface or cools beneath the Earth's crust, it solidifies into igneous rock. An important point to remember is that the cooling process can happen either quickly or slowly, which affects the texture of the rock. Next, we have sedimentary rocks. These form through the compression of sediments, tiny particles like sand, silt, or organic material that settle over time. The layers of sediment get compressed and cemented together, creating rocks like sandstone or shale. This process is crucial because it often preserves fossils and tells us about Earth's history. Finally, we have metamorphic rocks. These are rocks that have undergone transformation due to intense heat and pressure, usually deep within the Earth's crust. Unlike igneous or sedimentary rocks, metamorphic rocks change in mineral composition and structure without melting completely. Examples include marble and slate. Connecting this to the overall theme, understanding these rock types helps us appreciate the dynamic processes shaping our planet. Each type tells a story about Earth's history and the conditions under which they formed. All right, let's talk about igneous rocks. When magma, which is molten rock beneath the Earth's surface, cools down, it solidifies and forms rocks. These are known as igneous rocks, and they are often called primary rocks because they are among the first types to form in the rock cycle. The key point here is that the cooling process of magma directly leads to the formation of these rocks. This connection is important because it shows how geological processes create the very foundation of the Earth's crust. Understanding igneous rocks helps us see the origin of many other rock types and how Earth's interior processes shape our planet's surface. Now, let's take a look at the different types of rocks and some examples of each. As we discuss these, keep in mind that rocks are categorized based on how they form and their mineral composition. This helps us understand the Earth's history and the processes that shape our planet. First up, we have igneous rocks. These form when magma or lava cools and solidifies. An example of an igneous rock is granite, which is commonly found in continental crust, and basalt, which makes up much of oceanic crust. Moving on, we have sedimentary rocks. These are created from the accumulation and compaction of sediments, like sand, silt, and clay. A good example here is sandstone, often seen in deserts and beaches, and shale, which forms from clay particles settling in quiet waters. Lastly, we have metamorphic rocks. These are rocks that have been transformed by heat, pressure, or chemically active fluids. An example is marble, which can develop from limestone, and slate, which originates from shale. Recognizing these types and examples helps us understand the ongoing cycles of Earth's crust and how different rocks tell us about the planet's dynamic history. Let's talk about sedimentary rocks. Imagine rocks rolling down a hill or breaking apart when they hit each other, creating smaller pieces. These tiny fragments are called sediments. Now, these sediments don't just stay put. They get transported by natural forces like wind or water. Once they settle in a new location, they form layers through compression and hardening over time. This process turns loose sediments into solid rock layers, which we call sedimentary rocks. An example of this is sandstone, which is made from grains of sand that have been pressed together. So, in the bigger picture, sedimentary rocks tell us a lot about Earth's surface processes and history. Now, let's talk about metamorphic rocks. These are fascinating because they form from other rocks, specifically igneous and sedimentary rocks, when they are subjected to intense heat and pressure. This process causes them to undergo physical and chemical changes without melting completely. For example, clay, which is a sedimentary material, can transform into slate, a type of metamorphic rock that's often used for roofing. Similarly, limestone, a sedimentary rock made mostly of calcium carbonate, can change into marble, which is prized for sculpture and architecture. These transformations highlight how dynamic the rock cycle really is. They also tie into the overall theme of how Earth's processes shape and reshape materials over time. So, metamorphic rocks are like the result of nature's incredible ability to modify existing materials under the right conditions. Now, let's talk about the rock cycle. Essentially, one type of rock can transform into another type under specific conditions, and this process happens in a continuous, cyclic manner. That's what we call the rock cycle. For example, when molten magma cools down, it solidifies and becomes an igneous rock. These rocks, over time, can break apart into small particles, which are then transported by wind, water, or ice, and eventually deposited to form sedimentary rocks. But it doesn't stop there. When both igneous and sedimentary rocks are subjected to intense heat and pressure, often deep within the Earth's crust, they change into metamorphic rocks. And here's an interesting point. If the conditions are extreme enough, these metamorphic rocks can melt again, turning back into molten magma, ready to start the cycle all over again. This entire process highlights how dynamic and interconnected our Earth's materials are, reinforcing the idea that everything is part of a larger, ongoing cycle. It's a perfect example of how Earth's geological processes are constantly shaping and reshaping our planet. And with that, we come to the end of our presentation.